Hi, so we're doing problem set number 1, question 1. I'll skip the introduction of the question and straight on to question A. And here we're given the timing already, and we'll start with step 3, where the agent is gonna decide the effort 1 and 2 he's gonna choose, given the wage that the principal will offer. And we know that x1 is equal to e1. So to start off, we start using the agent's utility function, which is given here. And we see that the wage here, simply subbing what we know, is given by principal, and subbing x1 equal to e1. We get this equation here. Simple substitution. And because we want to find the maximum, the effort that's going to give maximum utility to the agent, and we start by differentiating this in respect to e1, and just take the derivative and get 0. This e1 disappears, and this part works slowly, differentiation, and set this equal to 0 for the maximum. And we just simplify this, and we get equation for e1 equal to beta minus half e2. And we will name this our equation number 1. Do the similar stuff for e2, set it differentiate it, set it equal to 0, and we get simplify into e2 equal to half e1, and that will be our equation number 2. So we have two equations with two variables, e1 and e2, and solve that simultaneously by subbing in e2 into here, and we should have e1 equal to 4/3 beta, and e2 is equal to negative 2/3 beta, and that is question A. And for question B, we will ask to find our principal's choices of incentive schemes that will maximize his payoff. And we know that the agent, because he is smart and he wants to minimize the wage he has to pay to the agent, and he will pay the wage that will result in the agent's utility function equal to the utility function he will have not having this job. And we do this little trick here. The utility function of the principal is equal to UP plus 0. Nothing changed here, and because we know that UA equal to U0 and UA minus U0 is 0, so we sub in 0 is equal to UA minus U0, and we have this here. UP is equal to this whole thing is UP plus UA minus U0. We sub in what we know from X for W. We can cancel these two out and sub in E1, E2 into the W's, and we sub in the E1, E2 we got earlier from question A, and we should have this equation here where there's a lots of algebra. Just simplify, should be straightforward. Simplify it down to this equation here, and because we want to find the maximum in terms of beta, so we take the derivative of this thing in terms of beta and set that equal to 0 again. Simplify, we should get beta equal to half. And since we know beta already, we can find out the alpha by knowing that UA is equal to U0, as we mentioned before, and we know UA is this equation here. Set that equal to U0. We have U0 equals to alpha plus sub in, because we know that E1 equal to 4/3 beta, and beta equal to a half, so we know E1 equals this whole thing here, and we do the similar for E2. Sub everything in E1, E2's, and just calculate the whole thing, and we get 1/6. This is the whole thing. So we get U0 equals alpha plus 1/6, and rearrange, we get alpha is equal to u0 minus 1/6. And these two together will be the incentive scheme that will maximize the principal's utility function.